Right. Hello guys. So today we're going to be looking at a simple algorithm to compute the square root of any number. So we have a number and we wonder like a number a and we wonder how we can find the square root of that number. And I mean, if it's a nice number it's easy, square root of 4 equals 2. But, what if we get into some other examples like square root of 2? Well, that's an irrational number, about 1.41, but it has infinitely many decimal points, so we can't really compute it in a normal way. But we basically know to an infinite precision what the square root of 2 is, even though it's infinite. So how do we know that? Well, there's a really easy way to actually do this. It's kind of I mean it's a really cool algorithm, and you have like it's really weird to think about, but it's actually really simple. First of all, let's try to construct a function f of x which equals x squared minus a. Now, what's special about this function? Well, basically, what are the zeros of this function? So when f of x equals 0, we get that x squared equals a, so x equals the square root of a. So this is a function where its zeros are exactly the square root, like the function equals 0 exactly when x equals the square root of a. So if we can find the zeros of this function, we can easily find what the square root of a is. But how do we actually do this? Well, there's actually a beautiful way to do it called the Newton-Raphson method. And basically, we can plot our function x squared minus a. It's just going to be a quadratic, but it's going to be shifted down by a. So, for example, I can do it in blue right now and just plot it like this. And basically, we want to find this value here, which is, the zero of the function. So what we do first is start at any arbitrary point. I'm going to do it in green. So we just, mark a point x0 and we check where it intersects with the graph. So this point here is f of x0, and then we draw the tangent to this point. So we draw the line which has an identical slope to the function at this point. It's called a tangent, and it intersects the x-axis at a point which we can call x1. And then again, we check where it intersects our function. This is f of x2, and we draw the tangent again. And as you can see, we're getting closer and closer to the actual intersection of the function with the x-axis. So boom, here it crosses the x-axis at x3. We go again here. Here's f of x3, the y value. We draw the tangent again, and we get very, very, very quickly, we get very close to the actual zero of the function. And if we keep on doing this, eventually we will get our tangent lines will exactly intersect the zero of the function. So really quickly, we can get the zero of basically any function. This works, I have a function right here. It's a bit more complicated, but we start at the point x0, check, draw the tangent, it intersects at x1, go here, this is f of x1, draw the tangent again, we get to x2, draw it again, x3, x4, and we get very close to the zero over here, very quickly. This basically works for any smooth function. And yeah, I mean it's easy to show graphically what's happening, but can we actually how do we actually calculate this? How do we actually calculate x1 and x2 and x3? Like, is it easy to also calculate where these tangents cross the x-axis? And the answer is yeah, actually it's really easy to do, which is quite surprising. So basically we want to find the slope of this line first, and what is the slope? Slope just equals rise over run, right? Rise over run, or y2 minus y1 over x2 minus x1. That's the classic equation for slope. So basically the height of this is just f of x0, so that's a rise, f of x0, and then the run is just this over here is just x0 minus x1. So x0 minus x1, and that is the slope of our tangent line. And the slope of the tangent line to the function is just its derivative at that point. So this is just the derivative of f at the point x0. And now we can just rearrange to find x1. So we put x0 minus x1 on the other side equals f of x0 over the derivative of f of x0. And now what is f of x0? We said this is our equation. This is f of x. So this equals x0 squared minus a over, what's the derivative? Well, a is a constant. It's the number that we're trying to find the square root of. So its derivative is 0, and the derivative of x squared is just 2x. So we get 2x0. So basically we put x1 on the other side. x1 equals x0 minus x0 squared minus a over 2x0. Here we just divide by x0. So basically we get that x1 equals x0 minus x0 over 2 plus a over 2x0, this here just equals x0 over 2. So we basically get that x1 equals 1/2, we can take it out, x0 plus a over x0. So that's what x1 is. It's so easy to find. If we know our initial point, and if we know, a, the number we're trying to find the square root of, we can find x1. And then we can do the same thing with x1 to find x2. So basically this is, we basically get a sequence where xn plus 1, so the next term of the sequence, equals 1/2 times xn plus a over xn. So we get, a really nice sequence pattern. And if we just, continue running the sequence, basically the limit as n approaches infinity will exactly give us, so basically the term x infinity will exactly give us the square root of a, which is such a clean answer. And we can see it geometrically here how it works. Basically we take infinitely many tangent points, and eventually we get so close to the point that these x's that cross the x-axis will exactly be the zero of this function, and the zero of this function is exactly the square root of a. So it's, we get a very nice sequence rule, and with this we can find the square root of any number. So here already I haven't, I just wrote some quick Python code. For example, where here a parameter, we're trying to find the square root of 2, and the first, or x0, we chose it as 2, and we can see that in 3 steps already our computer, our program gets to this value of the square root of 2 like very nicely already. So let's say we try to find the square root of, I don't know, 13. Again, it's so easy. It works so fast, and even we can take more steps. If we take 10 steps, but we can see the program works very, very efficiently. And here I'm always starting with the value. We can start with the value, for example, 10,000. We get that, we start with the value 10,000, and so still super quickly our program gets to the value. Right now we're trying to find the square root of 13 very efficiently. So yeah, it's a very efficient program. It's it's very nice. Most computers use it. Now they use slightly different programs already, but this is basically, this is how any computer can find the square root of any number very nicely and very quickly. So there's also like a proof to why this function exactly gives the square root of a number. It's like a very, I can also do it in another video if anyone wants. But yeah, that's basically it. So thank you for watching.